Hi there, this is Professor Eckhausen. I am talking today about writing and identifying characteristics of decimals. There's a lot going on in this section, from writing and naming decimals, which a lot of people don't know, they don't know how to do. So we're going to practice that. We're going to convert from decimals to fractions and ordering them on a number line and rounding decimals. This may be a long video, so feel free to take a break or skip to the part you need. All right, so make sure you have a calculator. You need a calculator for decimals. These are not things that you are expected to do in your head. Let me know immediately, please. If you still don't have one, I have a solution for you. You cannot use your phone on knowledge checks or exams for these, for this class. So one of the requirements was to have one or get this calculator. Okay, so if you already have one, I'm not asking you to get a second calculator. I will have some to borrow in class soon. All right, so naming decimals. So if we're on the whole number side of a decimal, we've got counting numbers, 1, 10, 100, 1,000, 10,000, and so on. So this is a base 10 number system. So every time we go up one digit, we go up times 10, right? So 10 times 10 is 100, 10 times 10 times 10 is 1,000. Another way to write that is 10 squared, or 10 cubed, or 10 to the fourth. Okay, but that's what we call them, 100, 1,000, 10,000. Now, when we go to the other side, people get a little confused because there is no 1/1, right? We skip the 1/1 place and we go straight to 1/10 because this represents 1 over 10. Okay, 1 over 10. And the next one represents 1 over 100 or 1/100th. The next one, 0.001, is 1/1000th. So if you put 1/1000th in your calculator and hit enter or convert it to a decimal or hit divide, you'll get 0.001. Okay, so that's how those work. Okay, so this is the decimal place value chart, taking all those things that we just learned. You might want to turn your head sideways and read. Here is our decimal point right here in the red. Okay, and then to the right we've got tenths, hundredths, thousands, 10,000s, 100,000s, and it does say 1,000ths, just to make sure that's really clear. And on the other side, we have ones. Notice there's no ones on this side. It's just tenths, so tens and tenths, hundreds, and look what place value they're in. Okay, so there's darker lines to separate every third one over on the left. Okay, so we need to be able to name decimals without saying points. So when we have a number like this, you've probably set it 251.27, but that does not help us turn it into a fraction, and that's what you need to know how to do. So naming it is going to help you turn it into a fraction, all right? So we need to know, we need this knowledge to convert to fractions. So what you're going to do is you're going to name the number to the left of the point, just like you always have, like 251 or 251. We're going to say and for the decimal point. Okay, so try not to say and like I just accidentally did. 251, we say and when we see the decimal point. And then we're going to name the number part to the right of the decimal as if it were a whole number. So this would be 27. And then you name the decimal place of the last digit. That's the hundredths place. So this would be 251 and 27 hundredths. Okay, and we're going to use that chart up above to figure that out. All right, so name each, and we're going to do this in class together, and then I'm going to have you do a few on your own. So first, let's try these together. So 5.7 becomes, and I'm going to come down here and I'm going to put this in my chart. Okay, so 5.7, so I can see the place value of the last one. So this first one would be 5 and I'm not writing all of these down because they get really long, but this first one I can write down 5 and 7, so you just say the name, this is and, right? Say the name of the number, so that's just a 7, and it is sitting in the tenths place, this place value right here. So we say 7/10. Okay? All right, the next one, 10.32 is going to be 10 and, so say and, 10 and 32 what? 32 what? Well, it's sitting in the hundredths place. Its very last digit is in the hundredths place. So it's 32 hundredths. So the rest of these, you may have to just listen to some of these if I can't squeeze them in. Okay, so I'm going to erase some of this so it's not there for the next one. All right, the next one, 0.009 is going to be, we don't have to say 0 and. Okay, so you don't have to say the 0 and. You're just going to, on this one, because there's no number here, there's nothing there, you're just going to say, what is that number right there? All we're looking at is this. Well, that is just 9. 9 what? Okay, so 0.009. It is sitting in the 1,000ths place, so you would say 9 1,000ths or 9 thousandths. Okay, so I usually say 9 thousandths. So that is different from thousands. There's no TH. I know, this seems so elementary, but it's so important for being able to write these as fractions. All right, next one. The next one is 0.0568. So this one would be, whatever this number is, 500. I don't say and, because that represents a decimal point. So just 568. And where does that sit? So let's see, 0.0568. The 8 is in the 10 thousandths place. So you had 568 10 thousandths. Okay. All right, next one. Negative, right? So you would say negative 23. And we often use a hyphen for 23, but you don't have to. And 337. I'm not going to write the rest of these down. I'm just going to say them. 37. Now, where is it going to sit? So we've got 23.337, and it sits in the 1,000ths or just thousandths place. So you would say thousandths. Okay? Negative 23 and 337 thousandths. All right, so go ahead and take a look at these next few, and you're going to name those. So pause the video and try naming them, and I am just going to do it verbally so it doesn't take me nearly as long, okay? So you're just going to have to listen when you come back. Okay, so this next one is, let's see, let me pick a new color. The next one is 0.0000355. So this one would be 355, and you look in the place value that it sits in, 1 millionths. 355 1 millionths. All right, the next one we would put in the 405, and, so remember, say this as and, at the point, 42 hundredths, because it lands in the hundredths place. The last digit is in the hundredths place. Okay, 405 and 42 hundredths. All right, next one. Ooh, that's a lot of zeros. So we've got 10 and 0.00396. So this one would be 10 and 396 1 millionths. All right, the last one, 63. So 0.063, and you put the 0 over there too. 0.063 is 63. Look at where it lands on the very last digit, 1,000ths. 1,000ths. All right, so that's it for those. Let's move on to given a name, write the decimal. All right, so we're going to do what we just did backwards. So look for the word and, it locates the decimal point. Mark the number of decimal places needed to the right of the decimal point by noting the place value indicated by the last word. So that's going to tell us the number of decimal places. Place a decimal point under the word and. Translate the words before the and into a whole number and place it on the left. If there's no and, write a 0 with a decimal point to its right. Translate the words after and into the number to the right. All right, then we're going to fill in zeros for placeholders as you need. All right, so number 4. Why don't you try these? Just try them, see what you can do with them. Okay, so here's our place value chart that we're going to use while we do this. So 7 and 8/100ths. So 7, and I'm going to erase these as I go because I only had room for this one. So 7 and 18/100ths. So hundredth is going to tell us where the last digit is going to go. Well, that's right here. So 18 fits in like that. So 7 and 18/100ths. So that's 7.18 like that. 7 and 18/100ths. All right, the next one. I'm going to erase all this and use it to do the next one. 204. So 204 and is the point. 25 thousandths. All right, so where is thousandths? So 1,000ths right there, 25 thousandths. So where does 25 go? Well, if I put like that, that would be 250 thousandths. So that's not right. So think about how it would go, and that would land like that, 025 to hold the place value. And that's what they mean by putting a zeros in to hold the place value. You've got to have it there somewhere. All right, so what they said above was to use spaces. So I know that thousands is going to be the third space over. So I'm going to go 1, 2, 3. So if you don't have one of these place value charts in front of you, this is how you would do it. You would just have to know where thousands are. You would say tenths, hundredths, thousandths. Okay, tenths, hundredths, thousandths. And you would say, where's 25? It would be 0, 2, 5. All right, next one. If you haven't tried one on your own yet, go ahead and pause it and give it a try. All right, so the next one is 638 10,000ths. So I don't see and anywhere. So that means it's going to be 0 point. So 638 10,000. So let's look at 10,000ths and see where that place value is. That's the fourth one. So if I didn't have a chart, I'd go 1, 2, 3, 4. All right, so I would figure out where 638 is. Well, I have to end at the 10,000, so that means there must be a 0 right here. You could also do that here. I have to end there, 638, and so I'm going to put the 0 here. 638 10,000ths. Okay, so that's how you do those. So, quick note: the number of zeros at the end depends on the context. So if I said $1 and I was dealing with cents, I would have to put the cents there. Would you ever say $1 with more than 2 place values after it? Probably not. Okay, so remember that 5 can be 5.0, it can be 5.00, it can be 5.000, and same with -2. I mean, anything, you can have more zeros depending on how many you need. In science, you want to look at significant figures, but right now we're just practicing. So we're not going to worry about significant figures. We're just going to practice figuring out how many decimal places we need, just kind of in the context, especially with money. All right, so now we're going to look at converting a decimal to a fraction or a mixed number. So here are the steps. I'm not going to read all these to you this time, so please pause and read through this and see if you can make sense of it. All right. So looking at the number to the left, that's going to be your whole number. Okay, so that's all I'm going to say about that. Look at the number to the left of the decimal. That's your whole number or 0. Determine the place value of the final digit like we just did, and then we're going to write the fraction. All right, so what I'm going to do is I'm going to use the chart. So write each as a fraction or a mixed number. Okay, so we've got 3.07. That is 3 7/7. Okay, so that means this is 3 7/7 is that. Okay, so tenths means over 10, hundredths means over 100. That's what we said at the beginning, over 1,000, over 10,000, and so on, right? I'm going to erase that because it's so tiny and it's a mess. All right, so that was at the very beginning. Okay, next one, 5.2 as a fraction is going to be 5 and 2. Now 2 is right here in the tenths place. So that means it's going to be over 10, 2 tenths. And we're not going to worry about reducing right now, but that would reduce to 5 1/5. All right. So the next one is negative. So just don't forget to put a negative. And there's going to be, if you look up here at this, if it's a 0, it just goes to a proper fraction. So if this first thing is a 0, it's a proper fraction, not a mixed number, because there's no whole number at the beginning. All right, so we've got 0.345. This lands in the 1,000ths. So this is going to be over 1,000. So 345 1,000ths. Okay, so see how similar this is to naming? You've just got to know the name of it tells you what the denominator is going to be. 1,000ths, you've got 1,000ths there. All right, the next one, I'll write this one over here. We've got 0.0, how many zeros are there? 1, 2, 3, 4. 1, 2, 3, 4, and a 3. So this is just going to be 3. Now there's no number here, so it's just going to be a fraction, a proper fraction, over 100 thousandths. All right, so we're in the 100 thousandths. So that's 100,000. You can use a comma if you need to keep track. 3 100 thousandths. All right, so example 6, let's continue on. So we're going to write these as a fraction or a mixed number. So you try this one now that I've shown you how to do it. And why don't you pause the video and give it a try. My dog is barking. Okay, so 0.63. 0.63. We're supposed to write this as a fraction or a mixed number. So this is going to not be a mixed number because it starts with 0 and it ends with hundreds. So this is 63 100ths. Okay, 63 100ths. I'm closing my window. All right, 63 100ths. We're not going to worry about looking to see if it reduces. It doesn't reduce because 63 and 100 don't share any factors. All right, the next one, 0.063. And that lands in the 1,000ths. So that means we get, what is this number? How would you say it? Well, you would say 63. And what place value is the last digit in? And that is in the 1,000ths, so 1,000ths. All right, the next one, 0.0063, 63 again, and it lands in the 10,000ths. So 10,000ths. And the last one is 0 point, and we've got 3 zeros, 1, 2, 3, 4, and oh, not 4, 3, 6, 3. All right, again, this is just 63, and it lands in the 100,000ths, so 100,000ths. Okay, so I just did that so that you could see kind of the progression of how that works. So take a look at that for a moment, pause the video, make sure you can see the patterns and make sense of all of that. All right, write as a reduced fraction or a mixed number. So this time they are asking us to reduce it if possible. Okay. All right, so this one we're going to say 2 and 24 what? Well, this place value right here is the second one over, that's hundredths. So 24 100ths. So try to learn this without having to have a chart in front of you. All right, so now this is going to reduce, and you want to say, I see a 4 in 24, and I know 4 goes into 100. So how many times does 4 go into 24? 6 times. How many times does it go into 100? 25. All right, so I get 2 and 6 25ths. All right, the next one, 4.45, is going to be 4. Again, it goes to the hundreds, so 45 100ths. And I'm going to look to see what reduces, and I see a 5 goes into 45 and 100 because they end in a 5 or a 0. All right, so how many times does 5 go into 45? 9, and into 100, 20 times. All right, so I get 4 and 9 20ths. All right, this next one is going to be negative. Now there's no whole number in front, so it's 836. This is tenths, this is hundredths, this is thousandths. So this would be 1,000 on the bottom. All right, so you'll just have to trust me here when you divide this by 4, or use your calculator. So divide by 4 and you get 209. And I know because 4 goes into 8 4 times, and then, sorry, 4 goes into 8 2 times, and then 4 goes into 36 9 times. So that's how I did that in my head, or you can use a calculator. All right, so that becomes, don't forget the negative, right? The negative is there, right there. 209, and then 1,000 divided by 4 is 250. All right, so 209 250ths, and that is the reduced version of that decimal. All right, next we're going to talk about locating decimals on a number line. So the first thing I want you to think about with these before we do that is to pay attention to how many divisions are between given numbers so that you can figure out what each division represents, okay? So let's see, we've got 1, 2, 3, 4, 5, 6, 7, 8, 7, 8, 9, 10. So there's 10 divisions here, right? So all of them have 10. So there are 10 divisions. So what does each one represent? Well, in order to figure it out, you're going to find the value between the numbers. That's what we just found. So that one is, we found it 10 divisions. So that's the number of divisions is 10. Find the value between the numbers. That is going to be the second number minus the first number. So that's 1. And then you're going to divide the interval, which is 1, divided by the 10. So each one is worth 0.1. Okay, so let's go back and say that. So each division here represents 0.1. What about this next one? Well, we've got 10 divided into 10 portions. So 10 divided into 10 is 1. So each one of these is just 1. 1, 2, 3, 4, 5. Count and make sure you get to where you should. All right, the next one represents from 0 right here, to 0.1. All right, so our interval is going to be 0.1 minus 0 over, or divided by, the number of intervals, 10. All right, so let's sum this up right here. I'm going to erase some of this mess right down here, and I'm going to sum it up instead. All right, so let's say that this is the interval divided by the number of divisions. Okay, the interval divided by the number of divisions. All right, so that's how you find that. All right, so now, and that's important to be able to make your own number lines. So locate the following on the number line and choose the number line that is appropriate for the number. Explain why to yourself, and I'll try to explain that to you. And do you need to approximate? All right, so the first number is 0.4. So which one should we use? Should we use the one that goes from 0 to 0.1, from 0 to 1, or from 0 to 10? Which one would make more sense? So if I said the first one, well, 0.4 would be over there somewhere because this goes only up to 0.1. This one, this next one, so let's talk about first actually, let's talk about what each division is. So we've got the interval of 0 to 0.1, so it's 0.1 divided by 10 divisions. And so each division actually in this one represents 0.01. So this is 0.01, 0.02, 0.03, 0.04, and so on. I'm just going to fill all these in so you can see it and believe me. All right, going from 0.09, the next one would be 0.10, right? So you get 0.1 or 0.10, however you want to see that. Okay? All right, the next one is going to be divided into tenths. So 1 divided by 10 is 0.1. So we get 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, like that. And the next one, hopefully you see that these is 10 divided into 10. Each one is just 1. All right, so the challenge with this one is, one, figuring out which one to put it on that it would make the most sense. So this first one, which one would we put that one on? And I'm going to say it should be on the second one. So let's call these 1, 2, and 3. So we'll call this one 2, this one is 1, and the last one is 3. And I'm color coding as well. So this one should go on 2, right? So 0.4 is right here. All right, 0.04, where do you think that one should go? Hopefully you see it's the first one, and that would be right there. All right, 7.3. Well, the first one only goes to 0.1. The second one only goes to 1, so we're going to have to use the third one. So this is the third one. 7.3, well, 7 is here and 8 is here, so 7.3 would be about right there. And yes, we are going to have to approximate. Approximate. All right, so I had to guess between the 2 points at about where it was. All right, 0.52, where am I going to put that one? So take a look, see which one you decide it is. And I think it's going to be the second one, because 0.52 would be about right there. Okay, it's between 0.5 and 0.6, and it's less than halfway. So again, we're going to have to approximate. All right, moving on. Locate the following on the number line. Choose the number line that makes the most sense and explain why. So these are negative. So let's look at what each one of these is. So this is going to be divided into 10. The first one is 0.1 divided into 10, so each one is 0.01. So we've got negative 0.01, negative 0.02, negative 0.03, and so on. Make sure you get to where you should be. The next one would be negative 0.10, right? So that's 10, or 0.1. All right, so negative 0.3 is going to not be on that one, because that would be way over there. So let's do the next one. This one is 1, or negative 1, divided by 10. So each one of these is 0.1. So we've got negative 0.1, negative 0.2, negative 0.3, and negative 1. All right, so negative 3 is going to go on, negative 0.3, I mean, is going to go on the first one, the second one, the orange one. And we're going to get negative 0.3 is right there. All right, the next one is going to go on the blue one, number 1, and that would be negative 0.05 right there. All right, the next one is negative 0.085, and I would say again on the blue one, the first one, 0.08 is here and 0.09 is here, so I'm going to say 0.085 is going to be right in the middle. Okay, negative 0.085 goes right there. All right, and the last one, 0.75, I'm going to say that that should be on the second one because it's way too big to go on the first one. It would be way off the graph there. So 0.7 is here and 0.8 is here, so 0.75 is in between. Negative 0.75. Remember, it's going in the opposite direction, so you got to think backwards, going to the left. All right, so what does each division or mark represent here? Well, we're going from negative 1 to 1. So our interval here, our interval is going to be 1 minus negative 1 over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 over 10. That is 2 over 10 over 10. So each one actually represents 0.02. Okay. So be careful when you do these on Lumen because they don't show you every single division. All right, the next one, order decimals using inequality notation. All right, so remember this is just a review. Use the appropriate symbol here. So pause the video and try both of these. All right, so 20 is less than 25. How do you say that? You're going to say less than. Always read these left to right. So read left to right, just like you do English. Okay, so negative 3, is it less than or greater than negative 7? So it is greater than. Negative 3 is greater than negative 7. All right, which is larger, 0.04 or 0.4? Think of money, right? So this would be like 4 cents, and this would be like 40 cents, right? So that's one way to think of it. Another is that 0.04 would be like, oh gosh, let's see, this is 0.05. So 0.04 would be about right there. And 40.4 would be here. This would be 0.40. So which one is larger? 0.40. Either way you want to think about it. Try to make sense of it in some way, either on a number line or with money or something that makes sense to you. All right, so there are 3 methods to order decimals. We're going to try all 3 to compare these 2 numbers here. And they do get harder than this. I just tried to give you simple ones so that we could put it on the graph and everything. One is to put them on the number line. So we put it on the number line and we get 0.05. 0.05 is right here, 0.05. And 0.008, well, that's going to be just a portion of 0.01. So 0.008 is right here. If you struggle with decimals, though, that might not be the easiest way to do it. So the second way is to convert to equivalent fractions. So first we convert to a fraction, and then we find a common denominator and we compare the numerator. I don't think this is the easiest way, but let's do it. So let's try the 0.05. So 0.05 is going to equal, so put this as a fraction. So that is 5/100ths, right? 5/100ths. All right, and 0.008 is going to be 8, but that's in the 1,000ths place right there, so 1,000ths. But now we want them to have a common denominator. So what can I do to 100 to get 1,000? And hopefully you see that that is times 10 over 10. All right, so we get 50 1,000ths. All right, so now they have the same denominator and we can compare the numerator. Compare the numerator. So which one's bigger? So hopefully you see that 0.05 is bigger, just like we did with the picture on the number line. All right, the next one is my favorite and the easiest, I think. Add zeros. So check to see if both numbers have the same number of decimal places. If not, write zeros at the end of the one with the fewer digits to make them match. And then compare the numbers to the right of the decimal point as if they were whole numbers. And then order them using the appropriate sign. Okay, so let's try it. We've got 0.05 compared to 0.008. Now, so what it just said is add zeros at the end of the shorter one, the one with fewer digits, so that now you can compare these two and say, well, this one looks like 50. Well, this one just looks like 8. They both go to the same place value now. Okay, so 50 compared to 8. So you would say again, the blue one is greater than. All right, so our final answer is going to be that 0.05 is greater than 0.008. Any way you do it, it should make sense. Okay, so real quick, I just want to make sure that you understand something. This is a little bit more space here. And that is that 0.05 compared to 0.050 compared to 0.0500, 0.05000, we could go on. They are the same number, right? They're the same. We're just putting zeros at the end, and you can do that with decimals, and they're still the same. They just go to a different number of significant figures. So let's think about this. This one is 5/100ths. Now, if I just multiply top and bottom by 10, which means I haven't changed anything, I get 50 1,000ths, which is what that is. All right, so now let's multiply that top and bottom by 10 over 10. And what do we get? We get 500 1,000ths, which is the same as that. So these are all equivalent fractions. And let's take this and multiply it times 10 over 10. And we get the next number, which is 5,000 10,000ths. Right? So all of these are equal because we're just multiplying 10 over 10 each time. Okay, so make sure you understand that all those are the same. It will make a lot of things easier. There's a video at the end of 5.1c, locating and ordering decimals with a number line to see how to compare a set of numbers using a table. I just kind of showed you, but there's a different method here that's pretty helpful, and I would recommend going to watch it. Okay, so this is just a screenshot, so you can't click on this. You have to go to the book. All right, so last topic is rounding decimals. So we're going to use your number line skills to make sense of rounding. So we're going to round 2.72 to the nearest dollar and then to the nearest dime. Okay, the nearest dollar and then to the nearest dime. All right, so where are our dollars? So our dollars is $2 and $3. Here is 2.72. So what is it closer to? Well, it's closer to 3. Right? So 2.72 to the nearest dollar means we're going to use this and figure out what it's going to do to that. Well, it's going to make it $3, right? $3. And that's what this is right here, $3 and $2. All right, the next one is to the nearest dime. So here we've got 270 and here we've got 280. And we want to know where 272 lies closer to. Which one it lies closer to. So, of course, it lies closer to 270. You can see it right there. So $2.70 as opposed to 280. So what if you weren't given a number line? $2.72. Think about the dimes place. When it says to the nearest dime, what is the penny going to do to the dimes place? Well, it's a 2, so it's going to be $2.70, just like we got on the picture. All right, so rounding a decimal, locate the given place value, mark it with an arrow, underline the digit to the right, and think, is it equal to 5 or greater? If so, go up. If not, stay where you are. All right, so try, this is our last problem, try these right here. Round this number to all of these different place values. Okay, so we've got 19.2583. We want to go to the tenths place. All right, so what is the 5 going to do to that? It's going to turn it into a 3 because it's a 5 or greater. So 19.3. All right, the next one, 19.2583, hundredths place. So that is this place value. What is this one going to do? Well, it's bigger than 5, so it's going to round this up to a 6. And we get 19.26. All right, next one, to the thousandths place. I'm going to just rewrite it every single time so we can look at it. So the thousandth is this place value. What is the 3 going to do? It's not going to round it up. It's going to keep it an 8. And we get 19.258. All right, next one, whole number. That means the ones place, right? Ones place. That's what it means. All right, so you should get 19.2583. You're going to look at this one and think, what is the 2 going to do to it? It is not going to round it up to 20. It's going to stay at 19. In other words, if I had 19 and 20 on a number line, where does 19.2 lie? Well, it's over here closer to 19. All right, the tens place is going to be 19.2583 is going to be this place right here. So what is the 9 going to do to that? That is going to round it up to a 20. All right, that is the end of this section. Thank you for watching.